Good? Okay. So I'm Laura. I'm doing the Introduction to Arduino workshop. This whole past summer, I did a couple of projects on Arduino and I got to know it a little bit better. So I thought it would be cool to work through it from the very beginning. So if you've never heard of Arduino or you don't know how to use it, this would be a great place to start. So what's an Arduino? It's an open source electronics platform and it's really easy to use and it's more hardware based. So Arduino boards are able to read inputs and outputs and they'll produce Is it working now? Okay. These are some projects that I did this summer. I spent a couple months working on the first one. I worked on it every once in a while until I figured out the basic functions. And then I did the Iron Man helmet with the help from my mom and dad that are also engineers. We designed it on Autodesk Fusion 360, and then we printed the parts and used multiple Arduino boards to connect them. And inside there's a bunch of servo motors and it opens up one by one. And we program the timing so that they open up at different times. So overview for today, I'm just going to do an introduction. It's more going to be less working on projects and more just what an Arduino is, how to pick the correct board, what shields are, how to use the language, more stuff like that. The other days is going to be more project based, so we're going to actually be working on stuff. But at the end of the day today, we're going to use Tinkercad to build a small circuit. This is what we're going to be building at the end of the course. It's a clock with a buzzer. So the buzzer is like an alarm, and you can program it to show the time, date, anything you want when the alarm rings, and you can change the time with the buttons. So advantages of using an Arduino, there's a huge community online. So if you log into Arduino Reference or Discord or basically anywhere, there's thousands of people that use Arduino and they'll answer any question that you have. It's also really easy to use. They come in free packs. If you go on Amazon or something, you can buy a pack for $40 with a bunch of parts that you can build anything with. It's really simple programming language. It's based on C, C++. It's not really C, it's kind of like a derivation of that, but it's pretty easy to use. They have some basic functions, and if you want to expand those, you can just download libraries. It has a variable input, so you don't have to use only one input, 6 to 10 volts with most of the boards. And it's built in analog to digital conversion. Disadvantages, some of them can be kind of pricey. I think the most expensive one is $45. The cheaper, most common one is $25, the Arduino Uno. You can't really program it in any other programming language. I mean, you can, but you have to have your own compiler or download someone else's if you want to program it in anything other than their language. It has a lot less memory than a Raspberry Pi. So if you're using something with a lot of programming and code, you might not want to use an Arduino. It doesn't have that much memory. You can expand the memory, but that'll just cost more instead of buying a Raspberry Pi. And it doesn't run an operating system. It's not a computer. So if you buy a Raspberry Pi, that's basically like a mini PC. Arduino is not like that at all. So if you want to connect it to the internet, Bluetooth, there are shields or extensions that you can add, but it would be better if you're doing an internet-based project to use a Raspberry Pi. By the way, if you guys have any questions, you can just ask. So this is the difference between an Arduino and a Raspberry Pi. This is the Uno. It's their most popular model. And the Raspberry Pi is like a mini PC. Classic boards. So these are the ones that they first created when they started this company. They're the easiest ones to use. They're the ones that I used for the Iron Man mask at first, and then I switched over. So they're really interchangeable. If you start with one, you can switch to another one later on since the pins are mostly the same. They have very basic features, and they're really good to start with because they have the largest support and community online. Nano boards. They're very small, so if you're doing a project where you have limited space, like the Iron Man helmet, you're going to put that on your head. You don't want like a huge board on top of it. So I switched it to a nano so that I could fit it in there. And they also come with embedded sensors so they can measure temperature, pressure, humidity. There's lots of different models. And they support machine learning. And the nanos are the only Arduino boards that can be programmed in MicroPython. MKR boards. So these are the ones that are more advanced. They enable Bluetooth, Wi-Fi, Sigfox, a bunch of connections, and they're low power processors. So they have secure connections, they connect to the internet, and they're great for prototyping projects, but they are more advanced, so I wouldn't recommend these if you're just starting out with Arduino. Shield boards. So these ones connect onto your Arduino and add extra functions. So for example, if you have an Uno and you want to connect it to the internet, you'd have to purchase one of these and attach it on top. But the problem with that is then you're paying for more stuff. So you're paying like 25 bucks for an Uno and then 25 bucks for a shield, and the price starts adding up. So some shield boards can only connect to other certain boards. So the one on top there is a therm shield, and it can measure large temperature ranges. You can't connect that one to the classic boards. It has to be connected to the nano boards. So if you want to buy a shield, just make sure that you check which ones it connects to, because some of them only connect to certain boards. Choosing a board. So Arduino has their own website. Let me show you. They tell you all about the boards. So if you go on there, they have a bunch of information on all the kits, about all the boards. It tells you what each of them does. You can see which one you want. You can also just research online what you want on the board, and people will give information. So all the information that I have on the slides is from the Arduino Reference website itself. So when you're choosing it, it's important to know what project you're doing. The first thing you want to check is check the processor chip for functionality and speed. If you're doing something that needs to be done really fast, you might need a faster processor chip. Double check what size you need. Smaller projects require smaller boards. How many input pins do you need? So some of the boards, like the nanos, have less inputs. These ones have less inputs than the bigger classic boards. So if you have something that's going to need a lot of motors or a lot of inputs, you'll probably want to get a bigger board. These ones I think have 12 inputs, and the Uno has 16. Check the operating voltage. Some of them operate between 3.3 and 5 volts, the Uno does, while the other ones can operate between 6 and 10 volts. So it depends on what you want. That's how you decide which one you choose. You should check if you need a shield, because that's obviously going to change the cost. And you should check if you need internet connectivity, because the most basic ones you can't connect to the internet. You need an additional shield for that, while the MKR boards can be connected to the internet. Programming. So to program it, you have to download the Arduino IDE. It's downloaded the same way as you would download like Visual Studio Code or something like that. You can find it at the software portion of their website, or you can use what we're going to use today, which is Tinkercad. It's basically an online place is created by Autodesk where you can simulate circuits, and you can also code on there too, so you don't have to download anything. It's C and C++ based, but it doesn't really have all the functionalities of C++ because it's not as advanced. And you can use MicroPython, like I said before, for the nano boards. So if you want to use another language, you're going to have to create your own custom compiler. You can find some compilers based on what I researched for Python that people have already written, but it's just so much easier to program in their language, and it's really easy to understand. You can learn it really fast. Libraries. So if you've used C++ or C, you know that you can include, you can see down there, the hashtag include and then a library. So Arduino is the exact same thing. If you want extra functions, you can just look up what function you want and then include it with the hashtag include. But if you're going to import it to your board, you're going to need to download that library to your computer. Board breakdown. Okay, so this is what the board that we're going to use today looks like. The first button is the reset button. It'll reset the code that you just sent to there, and it'll start it from the beginning. So if you wrote to the Arduino Uno, blink this light twice, and it starts blinking twice, then it stops. If you want to restart that whole thing, you just click it and it'll do it again. So the second one is the AREF. It's used to set an external reference voltage. This one's kind of confusing. It's more advanced. We won't really use it. The third one is the ground pin. There's one over here, and there's also two on the other side. So you can use any of those ground pins. It really depends on the way that you're building your circuit, where it's easier to place one. The digital input and output pins are up here. So these are all the pins that the Arduino has. I think this one has 14 pins for the Arduino Uno. This is where you would plug in if you have a motor or a button or something, you would program it to these ones. And then there's special ones. You can see that there's a tilde on some of them, this little line here. That's the PWM pin. So if you want to simulate analog output, it needs to be connected to those pins. So if you want to control like the speed of a motor, they're getting information, sending it to there, you need to plug it into one of those. We're going to do, later on when we build the clock, we're going to connect the potentiometer to some of these because it takes information and sends it to other things. 6, the USB connection. This is how you power your board, or you connect it to the computer. So if you want to send your code, you need to plug it into there, and then it'll send it, and it also powers it at the same time. There's also the TX and RX lights down here. So when you're sending code to the Arduino, they'll flash. And when it's done, it'll stay red. This is the microcontroller that they use. 9, let me see, 5. The power LED indicator. If it's on and powered, it'll be red. Sometimes my stuff won't work, and then I'll realize that it's not powered on. If you have like a faulty wire, it'll tell you. Voltage regulator. There's 2 on the Arduino Uno, they're down here. One of them is 3.3 volts and the other one is 5. So if you want to use something that's 3.3, you'll have to connect it to there. And the DC power barrel jack. So if you don't want to power it using this one, because that one has to stay plugged into your computer, you can just connect it to some batteries using this, and then you can take it anywhere, and it doesn't have to be anywhere near your computer. The last couple of things, the 3.3 volt and the 5 volt pin, the extra ground pins down here, and the analog pins. So the analog pins are over here. There's 6 of them. They can take signal coming from an analog sensor and convert it to digital. So like I was saying with the potentiometer, you need to connect it to an analog pin. Input devices. So there's a ton of input devices that you can buy online. You can buy kits that come with like 20 or 30 inputs. Arduino makes some, or you can get it like Chinese ones really cheap. Some of them don't work though, so make sure you read the reviews. So any device that sends information or data to the Arduino is an input device. They all come with schematics when you buy them, or you can just look them up online. That'll tell you exactly how they need to be connected. And you can use Arduino Reference to get more information. So one of the classic ones, like the first one that they give you, is the keypad. So if you go to Arduino Reference, it'll tell you exactly how it needs to be connected, how it needs to be programmed, if you need to download a library to use it, and it gives you a little schematic of how you can program it. So these are some examples. Let's see, this one is a temperature sensor over here, a smoke detector right here, fingerprint sensor, a sound sensor. These are all things that are going to take in information and then send it to your Arduino. Output devices output information. So for example, the LCD that we're going to use is outputting information. We're going to use it to output time and date. So sometimes a library is required. Most of the time, not really, because they're very simple. So complex outputs have schematics and libraries available on Arduino Reference. So when you use the LCD, we're going to go through this later, you need to program it exactly this so that it'll work. Otherwise, it won't output anything. But they give you all this information so you can follow it, and it's easy to use. Some examples, LEDs, they output light, motors, liquid crystal displays, relays, speakers, buzzers, they all output something, sound. Adafruit. So Adafruit's an open source hardware company. They are great because they have really cheap versions of what Arduino produces. So if you don't want to buy a really expensive Arduino device or input, you can just go to Adafruit and get like one that's really similar for cheaper. Here, if I click on the link. So they have all these parts. They basically have everything that Arduino produces, but cheaper. Tinkercad. So we're going to be using Tinkercad today to build a beginner circuit. It's really simple. It's only using one LED. It comes with the Arduino IDE and it uses Scratch as well. I don't know if any of you guys have used Scratch. Have any of you? Yeah, it's like the blocks. Yeah. It's really easy and it'll convert the blocks into the Arduino code. So this is the one that we're going to build. If you have your laptops, let's all go to Tinkercad, and if you don't have an account, you can create one right now so we can build this circuit. Is everyone on there? So I'm going to click new over here and I'm going to do circuit. So this is what Tinkercad looks like. If you go up here to code, this is where you would write your code. Once we have something up, it'll start programming by itself. So the first thing that we're going to want to do is search up over here for an Arduino Uno board. And you can just drag it in. And I'm also going to look up a breadboard. Oh, I cannot see. The thing about Tinkercad is it's very limiting. Doesn't really have everything that you, if you're building something more advanced, it won't have all the parts that you need. So we're first going to build an LED. So you can look up an LED and choose whatever color you want and connect it somewhere on the circuit. So we want to connect, I can't really see on there, but yours should be clear. We're going to do a 5-volt voltage source. So if you can see on the Arduino, it'll say,
Other side. Right next to
it'll say 5 volts. You want to connect it to the red one, which is obviously input. And then the ground you'll connect over here. You can change the color of the wire by clicking on it and then going up here. I'm going to change it to red just because it's the input. Have we all done that? So then we need to connect the negative side of the LED to the negative terminal over here on the breadboard. So the negative side is the shorter side. You can see it. You can't really see it well on there, but on yours, you should be able to see that one side is longer than the other. So I'm going to go back to here. I calculated the resistor that we're going to need to use for the LED so it doesn't burn out. I mean, it obviously won't burn out because it's on Tinkercad. But if you were doing this in real life, you would need some sort of resistor for the LED. So I calculated how much it would need to be. The average LED, it's good to have a 25 milliamp current. So I just used the 5 volts, divided that using Ohm's law, and got 200 ohms. So that's what we'll need. 200 ohm resistor connecting in there. You can just look up resistor and then set it to 200 ohms. Cool. So it should look like that. You should have connected from the resistor to the positive terminal. So when you build something on Tinkercad, it automatically loads up this thing, which sometimes is not relevant to what you're building at all. So I'm just going to toss this one. We can start from the beginning. So when you go on here, there's lots of different blocks for Scratch. The first one, if you want to start it, you need to have a start block. So the control start block. This will start your code. You can also, let me do the blocking text so you can see what it looks like on the Arduino. So to get both of them, the Arduino IDE and the blocks, you can go to up here to where it says blocks and switch it to blocks and text or just text. So we're going to want this to work forever. So I'm going to use the forever loop. So as long as it's powered on, it's going to do this. So we're going to need to set this one. I set it to there, but we're going to need to connect it to a pin, a digital input pin. So pick whatever pin you want. I'm going to choose 9, I guess. So when you go to output, there should be one that says set pin to, and then a drop down. So whatever you set that pin to, mine is 9. I'm going to click 9 here. High means it's going to be on. Low means it's going to be off. I'm going to set it to high first. So when I turn on, when I run the simulation, it'll stay on. So we can, I'm going to close this and start simulation. So it turned on and it tells you the current going through it. So you can stop the simulation. Did everyone's work? Oh yeah. Yeah. Did yours work? So the next one I'm going to do is just a blinking one. So does anyone know how we would do that one? You can try to find in the controls how to make it blink on and off. There should be one in the controls. Wait. So when you use wait, and you'll see here on the side that the wait is equivalent to delay. So Arduino uses it in milliseconds. So if you want to delay 1 second, you need to do 1,000 milliseconds. So that's how Arduino works. And the wait is delay. So that's the function that you use. So when you run it right now, it'll turn on and then it'll wait 1 second. Then it'll go back and it'll still stay on because we haven't turned it off yet. So we can set the same pin to low, so it'll turn off. And then we'll wait another second for it to turn back on. Is it turning off and on? Can't really see from
Turning,
on.
yeah, it's turning off and on. Do it again. Off.
Well, it should be blinking. So I think my code is right. Set pin 9 high. Wait 1 second. Should be working. I mean, the code's right. Did everyone get theirs to work? No. Did you write the exact same code as me? Did you plug it into, what pin did you use? Oh, that's great. And no. Let's see. I'm gonna switch it to 8. Dang, I built it on this laptop. It's working fine. Let me build it again. Did you get used to it? Let's see. Everyone got theirs to just light up, right? Oh, what is it? Yay, okay, I figured it out. I had accidentally connected it to the red bar here. It should connect directly from the resistor to the pin. Did it work for everyone now? Did you guys' work? So you have to set this one to low, so it'll turn off.
So this little
200 ohms. So when it automatically sets to ohms. Can you go back to your code? So you have it set to pin 8 on there, but you wrote pin 9. Cool. So everyone's got theirs to work now? I had done the connection incorrectly, but now it's working. You have to connect a wire to it. Yeah, you can't change the actual size. Yeah. So if I'm going to stop the simulation, if you go to the code,
Get a question online. How can I check?
it should tell you if you run the simulation. So if you scroll over the resistor, it'll tell you right now. So someone asked how you can tell the amps and the volts. So if you go over the resistor, let's see where to go. It'll tell you what current is running through it. Yeah, if you hover over it. Mine keeps disappearing. Yeah. I don't know if you can see it. It keeps appearing and disappearing.
Is there a sidebar?
No, you can just hover over what you want. Right now, we don't have any voltage sources or batteries or stuff like that, so we can't check that one, but we can check the current of the LED. Did that work for everyone? You hover over it? Here. Me? I'm gonna try. There you go. It's because it's blinking. That's what he said. Yeah. So the current turns off, like the current stops and goes back. So if you have it just in steady state, like I do, just no blinks, it'll tell you. It can't be blinking because then the current. See if when you stop the simulation, if it'll tell you anyway. I don't think it will. Tinkercad is very basic. That's the downside to it. So later we're gonna do some variables. So the good thing about Tinkercad is you can create any variable that you want. So if you add in more stuff, you can create variables for that. So I'm gonna bring back the code that I originally had. So this is what it looks like when you first start it. It automatically starts you off with the void setup and the void loop. So the void setup is not going to change. So whatever you set in there, it can't be changed. So we're going to learn the syntax later, but basically pin mode is 8. So we're setting pin 8 as an output. Since it's outputting light, it's an LED, it's an output. So this isn't going to change ever. The void loop is where you actually put your code. It's like the main loop. And here's what we're telling it. We're digitally writing high to pin 8. So we're turning it on. That's what we said over here in the blue. And then we're delaying 1 second. And then we're writing it to low. So we're turning it off. And then we're waiting 1 second. And since it's in the void loop, it's just going to run that forever until you turn it off. So for this last portion, I reserved it to kind of be a good way to look through Tinkercad. So I'm going to okay, that's one thing that really annoys me about Tinkercad is if you click a wire and then you click out of it, you can't just leave a wire. You have to finish the connection before you can delete the wire. Yeah, but I mean, like, if you want to click somewhere else, it'll just leave the wire like that. You have to actually set it somewhere and then delete it. No, you can click on a wire. No, I mean, if you just like, if you don't want to click any buttons, just want to click somewhere else. I'm saying if you don't want to click, okay, y'all are so judgy. So what you can do, I'm going to delete this one right now. You can delete it too if you want, or if you want to save it and open a new one, you can do that. Tinkercad is like Google Chrome. It automatically saves what you have, so you don't have to save it. But if you delete this one and write something on top, it'll delete what you have. So if you want to leave this one in your account and start a new one, you can do that, but I am not going to. So what we're going to do for the rest of the time is if you look over here, you can search up. I'm going to search up Arduino. And there's already a bunch of free boards with a bunch of stuff. So if you don't want to go through the effort of figuring out your own circuit and programming it, they already have some. And it's good that you learn how you can do it. You can learn the code. You can pick any random one. I'm going to pick a simple one. Let's see. Something like this. And it already comes with the code pre-programmed into it. And you can start the simulation. And it'll run exactly as it says. And you can also add on to it if you want, so make it your own. So for the rest of the time, if you want to mess with the stuff that's already written on here and try to build your own, this week I was looking at the one that has the 3 speakers and I was trying to get it to output stuff. So if you want to look through that for the last bit, and I'll come around and see if you guys want to know a bit more. But we can get used to using Tinkercad, because for next week, we're going to be doing like 3 or 4 Tinkercad projects, and you need to know how to use it and understand how to use the blocks. So, let's see if I can. I have on here just to show you guys. This is an example. What we're gonna do on the 3rd day of the workshop. So this is how you plug in an LCD. This is what I built. I built this one. First, I built it at home on an actual Arduino, and then I just transferred it over to here. I usually though whenever I'm working on a project, I usually build it on Tinkercad first, and then I build it on here, because when I was building the Iron Man helmet with my parents, we burnt a lot of resistors and capacitors. So it's better if you just build it on Tinkercad first if you have a lot of stuff going on, because it'll tell you what's going wrong and you don't have to be desoldering and soldering on a bunch of parts. So for next week, what we're gonna build, the first thing we're gonna build is a servo controlled by a potentiometer. So if you guys want to attempt to build that today before we go through it tomorrow, see if you can use the Arduino reference. And also on here, it'll tell you information too about how to plug it in. So if you hover over stuff, it'll tell you the terminal. Not while the simulation is running. You should be able to, not on the. They just changed the hello world. That's interesting. Maybe just try to refresh this. It should let you edit it. Here, try to build your own. LCD, that's the 4 input one. That's the multiple input LCD though. You need the one that has like the 4 phones. That one. Yeah. I didn't see how the other one was connected. So you have to go on Arduino Reference and see what each of the pins has to be connected to. It might tell you if you have a little bit.
Well, if I use a breadboard.
You don't have to use a breadboard for that one because it only has 4.
Yeah, but
You have to connect it through the wires.
through the wires, I can just use wires.
So look up the schematic for what that is.
Oh.
Here, wait, let me just pull it up on there and you can copy the ones. It was this one, right?
It's like you can't see it on there. It's like, super.
Oh, is that? Let me see. No, I don't think so. What we're trying to do right now is she tried to change the hello world and we can't get it to change. Yeah, this one changes. Yours not. Yours isn't changing. You can change it. It's gonna run forever. Through the blocks. Oh, it's probably because you have the block and screen thing open when you tried it first. Yeah. What's the code for this? Is it just gonna count forever? Yeah. Has anyone found any interesting one? I know they have some interesting things. I haven't looked at all of them. So when we build the alarm, I didn't include this in mine, but you can, if like at a certain time you want the alarm to ring, you can display a message. I actually built one of these at home. It was supposed to wake me up, but the speaker that I used was not loud enough. So now it's just decoration. So there's two types of LCDs. There's this one. We're gonna go through it later, but this one has multiple inputs. It's a lot harder to program, but it's also a lot cheaper to buy online. This one is like a more modern version. It only has 4 inputs, so it's really easy. The programming is easy, but this is the one that I'm using because you can customize it more. I think this one comes back if you like actually buy the product. On the back it comes with something that modifies it, so you have to actually buy that separate part or buy them together. So it ends up being like $10 extra for each one that you buy. So if you're buying, like, I bought a pack of 5 or something and it was $50. If you buy this one with the 4 input, it ends up being like 100 or something. So it's not worth it to go through a little bit of extra effort to put in these wires. So on Tinkercad, it doesn't really show it very well, but turning the knob will change the brightness of the screen. On Tinkercad, for some reason, it just gets rid of the words. Doesn't do. So before we end for today, next week, I think we're going to build, if I remember, 3 or 4 different circuits and go through how to actually program them, because right now you're just clicking on stuff and all the programming is already there. But next week we'll actually run through the programming so that we can set up a baseline for the next 2 days, because then we'll actually need to program all our stuff and design the circuit. And it gets a little bit complicated because everyone's already done a little bit of programming, right? It's not like really advanced stuff. It's pretty simple, but if you've never done it, it might be a bit much. So we're going to do 3 examples: time function, a motor example. Some DC motors are kind of hard to use because you need a microcontroller. A servo example, and also another time example. And then day 3 is when we'll actually start building the clock. So this is what it looked like when I built it. The first time that I did it, instead of using a buzzer when the alarm rang, I used a motor and it would spin something because I thought that was cool, but it was really inefficient because spinning does nothing to wake you up. So then I switched it to a buzzer, which you can switch it to anything. You can switch it to a speaker, you can make it play music, you just have to learn to code that. So cool, does anyone have any questions? You won't need to download the IDE until day 3, but the IDE is really easy to download. It's only like 100 megabytes or something, and we'll go through that. You good?
Round of applause. Oh, do we, quick question online. Do we need the keyboard and
Day 3, we're going to build it on Tinkercad before we build it in person. So if you don't want to build it on the actual board, you can build it on Tinkercad. That's what we're going to do at first. We'll build everything on Tinkercad before we build it on the actual boards.